Greetings, Calc 3 students. This question is from Chapter 14.5, number 11 in your textbook, and that corresponds to number 6 from 14.5's homework. So we are given that we have a function named z, and that function named z has variables r and theta, so e to the r times cosine of theta. We're also told that there's a function named r that has variables s and t, so r equals s times t, and we're told that theta is equal to that function also of s and t. So s to the 6 plus t to the 6, all underneath the square root. And we are asked to find the partial derivative of z with respect to s, and by the way, we are also asked to find the partial derivative of z with respect to t. So we will worry about that second part in a minute. So what I like to do when dealing with a chain rule is just remember that I have this dz ds, and I'm going to write two copies. This is the first copy I'm going to write, and this is the second copy I'm going to write. And I write it as the partial derivative of z with respect to s and the partial derivative with z with respect to s. See, I've written it twice here, those partial derivative signs. But I've written them kind of funny. And remember from Calc 1 that the chain rule, when I had the partial derivative or the full derivative of, let's say, y with respect to x, that was the non-partial derivative, I could rewrite that with a chain rule, right? So dy and then dx, and then I had something else like dw, dw. That's what I did in Calc 1 with, not with partial derivatives, but with full derivatives, right? That was the chain rule. And then I would say, well, this is why they call it the chain rule, because this thing makes chains, right? That's the idea. So we're going to do exactly the same thing up above here with the partial derivatives, right? So I'm making a chain on this first one after I wrote a copy of that, and I write two copies, and the reason I'm writing two copies is I have two variables. One variable, two variables, I write two copies. So what do I put in the first one? Well, it doesn't matter which one I pick one or the other, but I'm going to do dr. So the partial derivative of r, and then the partial derivative of r. And then for the other one, I'm going to do theta. So the partial derivative of theta, partial derivative of theta. Okay, now I just need to follow along what's written here. So I need to find the partial derivative of z with respect to r. So the partial derivative of z with respect to r is e to the r times cosine of theta. Then I need to multiply that by the partial derivative of r with respect to s. The partial derivative of r with respect to s. So that's t, so multiply by t. And then plus the partial derivative of z with respect to theta is minus e to the r times the sine of theta. Okay, so that's the partial derivative of that with respect to theta. And then finally, I need to take the partial derivative of theta with respect to s. That's what this part is asking me to do. So I can do that. So I have 1/2 times s to the 6 plus t to the 6, and then raised to the negative 1/2. Then I need to apply the chain rule with respect to s. So that's 6 times s to the 5th plus 0. And now I'm finished. I can make that a little bit simplified. So e to the r times cosine of theta times t minus e to the r times the sine of theta. And then I can write s to the 5th times s to the 5th. And then this half and this 6 put together makes a 3. So I'm going to write a 3 out front. And so I've taken care of this and this and that and that and the s to the 5th. So now I just have to take care of this part to simplify. And so all I'm going to do then is divide this by s to the 6 plus t to the 6 and the square root on the bottom. So that's the idea. The problem also asks us to take the partial derivative with respect to t. So once again, I have two variables, two variables of z. And so I write two copies, partial derivative of z with respect to t plus partial derivative of z with respect to t. And then I just fill in the other variables, which is r and theta, right? I fill in this variable and that variable in my z function. So partial derivative of r, and then partial derivative of r, and partial derivative of theta, partial derivative of theta. And I will let you finish that problem out for yourself. Okay, if you have any questions, let me know.